My name is Aaron, and this is my FRQ test corrections. And for number one, we're asked to derive an equation for the vertical coordinate y of the sphere as a function of x, VO, and physical constants as appropriate. And I'm going to start off by grading my thing. So on the test, I did start with y equals xo plus vxo t plus 1/2 at squared, and for the x one, I already simplified it, but I did start with the same equation. But on the test, I didn't realize that the initial positions were just 0, so I could cancel those out. But that does earn the point for using the appropriate kinematic equations for the horizontal and vertical motions, but I couldn't figure out how to combine them, so I just got stuck and didn't complete it, so that doesn't get the point, so that gets a 1 out of 2 for this part. And to solve it, we know that since we're let's launch this way, we know that our acceleration is 0 for the x coordinate, so we'll do ax equals 0. Since we know we're only launched with the velocity going this way, we know that our vertical velocity is 0, so we get y equals 0. And then we'll start with the equations. So we'll do x equals x t equals plus 1/2 at squared. And since we know that acceleration is 0, we'll cancel all this part, and we're left with x equals vxt. And for our y component, we'll do y equals vyt plus 1/2 at squared. And we know that the initial velocity is 0, so we'll cancel that, and we'll get y equals 1/2 at squared. Since we need to combine these, we know that they both have t in common, so we could isolate t in this equation. We would get t equals x over vx. We'll plug that in here, and we're left with y equals 1/2 x over vx squared. And that would be the answer for number one, or yeah. Now for number B, we're asked to create a procedure to prove that y is proportional to x squared. And down here we need to list what's a measure, what's the symbol for it, and the equipment. And yeah, we also have to create the procedure. So it's right here. So one point is earned for listing relevant equipment, and that's the meter stick to measure the x and h, so that earns this point, this point, this point. And we do reduce the uncertainty by using different heights and repeating it 5 times with a certain height, so that gets that. And by doing this, it would prove that the claim would be true using our equipment, so I just get this point for 5. We would start with the quantity to be measured. During the test I did have the stopwatch, but that wasn't needed, so we just measure the height. We'd use y for that, and use the meter stick. And for the other, it will be the x displacement. We'd use delta x, and we'd use the meter stick as well. And yeah, so our procedure, it would be set the launcher to height and measure the height. Step 2 would be measure how far launch the ball and measure how far it goes. Step 3 would repeat this at least 5 times to reduce experimental uncertainty. For step 4, we would repeat steps 1 through 3 to get values. For part C, we're asked students want to use the teacher's data to prove that y is proportional to x squared is true, and we do this part. And for down here, for the first part, I didn't realize that this was supposed to be this part was supposed to be squared, or not. This part, and we would have had a x squared m squared, and it was squared. These values are here, and I didn't realize that, so that meant that the units wouldn't have been right and the axis wouldn't have been right, so that's no points for that. And that meant that the data wouldn't be right as well, so that's, yeah. So to do it correctly, we would do we'll square all of this, we'll get x squared m squared. When you square this, you get 0.251, 2.25, 4, and we'll graph it. Here, and for this we'll label it as y in meters. For our x, we'll label it as x squared m squared. And for our values, we'll use 0.2, 0.4, 0.6, 0.81. For x, we'll use 1, 2, 3, 4, and 5. Let's graph it. We'll start with our first values. Maybe like around here. We'll go like around here. 1, 5 will be around here. And like right there. And 4 will be around 9.9, so it'll be here. We need to draw our line of best fit, so it'll be something like that. And this does support our claim. So what I did wrong for this was ended up I didn't graph the thing right, so my thing kind of looked like a parabola, and this resulted in me having the wrong explanation and saying that this was not proportional, so I didn't get the point. And, yeah. And to do it correctly, since we know that the linear graph is proportional, and since this one is linear, that means that it's proportional. And since my graph wasn't linear, I just thought that it wasn't proportional, and that resulted in me getting it wrong.